Okay, good evening. So last week we did the third day of vectors. The silence. This online class sound is okay, no? Yeah. So no, silence. We did the third day of vectors, and in the third day of vectors we discussed about the application silence, the application of alpha a plus beta b is equal to 0. And I told you there are mainly there are three ways that how we can approach this type question. So one way is that we can apply the vector addition after having this lambda mu constants or alpha beta. We can apply the vector addition to a given triangle and build a relationship between the vectors. So I told you when we apply in this theorem, this alpha a plus beta b equals 0 theorem, we need to build a relationship or a connection between the vectors and the unknown terms. So if you are working with the vectors a and b, o, p and q, we need to have an expression written in terms of the vectors and the unknown terms. So the unknown terms will be alpha, beta, or maybe lambda, mu. We have to use them. So there are three main ways. One way is that applying the vector addition. The second way is writing the same vector in two ways. If you can remember, we did one past paper question, if I'm not mistaken, the 2021 question, where we had to find the vector OE, a similar vector, in two ways, and we can make the two vectors equal. So that is another way. And the last way is by comparing or considering parallel vectors, we can build an expression between the vectors. But if you can remember, I told you when we apply in this equation, make sure that we have two unknown terms. So we can't only have one unknown term and apply this equation. I told you if you're going to use this equation, we need to work with two unknown terms. Only having one unknown term, maybe lambda or mu, you can't approach the question. There should be, for sure, there should be two unknown terms. So I have given few homework questions, three past paper questions, and I think three questions from the TUT. Out of the past paper questions, I'll do the 2014 past paper question. So turn to page number 8, the 2014 past paper question. Other than this one, I gave 2013 and 2012 as homework, and I asked you to do up to question number 18 in the TUT. Question number 18 in the TUT. Okay. Okay, so there are a few questions asked in the online chat. I'll address them later. So let's start with the 2014 question. If you have done the question, good. If you haven't done the question, very good. So you can start the question now. I'm not going to give time to do the question now. But if you haven't done the question, do the question with me, because at the end of the class, I need to see this question written in your book. Okay, so let's see the question 2014 A levels. ABCD is a trapezium such that BC is equal to half AB. DC is equal to half AB. Also let AB equals P and AD equals Q. So we have a trapezium. So what is a trapezium? Yeah, there are four sides. Okay. It's a quadrilateral. So what is a trapezium? Tell me. What is a trapezium? Yeah, there are four sides. It's a quadrilateral. Okay, same meaning. Four sides means it's a quadrilateral. What is a trapezium? A quadrilateral where a pair of sides are parallel to each other. That's all. That is the only thing to be a trapezium. A pair of sides should be parallel, not both the pairs. Okay, if both the pairs are parallel, we call it as a parallelogram. So in a trapezium, only two sides are parallel. So we have the trapezium in this way: A, B, C, and D. Tell me the reason why I have taken AB and DC as parallel. Read the question and tell me the reason why I have taken AB and DC as parallel sides. Tell me the reason. Because they have given, if you can see, they have given that DC vector is equal to half AB. What is the meaning of this? What is the meaning? One vector has been expressed from the other in terms of the other vector, which means the two vectors are, you need to talk. The two vectors are dependent. Dependent vectors are parallel. So because of this reason, I know that the side DC is parallel to the side AB because they are dependent vectors. So that is the reason I have named the figure in this way. And they have given this vector as P and this vector as Q, AD. And then I know this becomes half Q. This becomes half Q. This becomes half Q. And now mark the data. E lies on BC such that BE is equal to 1/3 of BC. It should be BE. E lies on BC, silence, such that BE is equal to 1/3 of BC. BE is equal to 1/3 of BC. Yeah, this is half B. Okay. BE is equal to 1/3 of BC, which means the ratio, if BE is 1, the entire one is 3, which means this part is 2. If this is 1, the entire part is 3, which means this is 2. Okay. Then F is the point of intersection between AE and BD. Between AE and BD, the point of intersection is F. BF, they have given that BF is equal to lambda BD. Okay, they have given that BF is equal to lambda BD. So they have given that. Okay, first thing, show that AE is equal to this. Okay, I need to find AE. So how you can find AE? I'm going to write AE as AB plus BE. Consider the triangle ABE. Using the triangle ABE, I can say that AE is equal to AB plus BE. AB plus BE. Then AB is equal to P, and they have given that BE is equal to 1/3 of BC. So what is BC? How can we find BC? Starting from B, I need to go to C, and we need to add the vectors that I meet meanwhile. So I can go from here to here, this one to this one, and from D to C, which gives me minus P Q plus half P. Clear? Minus P Q plus half P. So I can write BC in this way, starting with a minus P plus Q plus half P. Okay, so this is clear. It gives you, this is minus P plus half P gives you a minus half. Gives you a minus half. So when you multiply, it's P a minus 1 over 6P plus 1 over 3Q. So then you get vector AE is equal to 1 minus 1 over 6P plus 1 over 3Q. So 1 minus 1 over 6 is 5 over 6. So then I have the vector AE is equal to 5 over 6P plus 1 over 3Q. So I get this vector AE is equal to this. Then show that AF is equal to this. So how can we directly write this AF? It's clear that they have given they have given AF is equal to an answer in terms of lambda. Now look at this. I am supposed to show that AF is equal to an answer in terms of lambda. And what is lambda? Lambda is that BF is equal to lambda BD. BF is equal to lambda BD. Okay, now look at this. I'm going to consider the triangle ABF. I'm going to consider the triangle ABF. And then I can write that AF is equal to AB plus BF. AB is vector P and BF is lambda BD. So how you can write BD? Okay, what is BD? Look at this. BD is minus P plus Q. BD is minus P plus Q, which gives me this is equal to minus P plus Q. Then I get P minus lambda P plus lambda Q. Then I get that AF is equal to 1 minus lambda P plus lambda Q. So this is what I get as the vector AF. Both are given answers. So there are two errors in the question you need to make. One is that second line BC such that BE is equal to half BC because they are referring to the point E. And fourth line, final one, it should be AF equals 1 minus lambda P plus not phi Q. This one should be lambda Q. Okay, hence find lambda. So I'll give 5 minutes. If you haven't done the question, quickly come up to here. Only 5 minutes. Quickly find these two vectors, vector AE and vector AF. Vector AE and vector AF. Only 5 minutes. Don't copy paste the board, do it alone. Small stuff. Only apply in vector addition. Come up to this stage. No silence, come up to this one. And so there were a few questions. One thing, have we finished sine rule and cosine rule of in trigonometry? No, that is that what we will be doing in December, trigonometry, sine rule and cos rule. And what else? What is the lesson that is happening today? I'm a new student. Okay, so today we are in the fourth day of vectors. So what I recommend is like if you stay in the class, you won't be able to understand this because we are in the fourth day. No? So the best thing is take your time to watch the previous 3 recordings and then you do the question. I'm just addressing the online students because half of the students are in the online class today. And then, so what I recommend is first watch the 3 recordings of vectors, and then after this recording is uploaded, you can watch this and continue the lesson because next week will be the last week of vectors. And meanwhile, we have done 2 additional lessons this month, coordinate geometry and logarithms. You can watch them because those are 2 independent lessons, not connected to any previous lessons. And how to receive the tunes, all the information have been given in the group. But if you are not in the group and if you don't know any of, but it can't be that you are not in the group. If you are watching the recording, that means you should be a registered student in the website. No, so if you don't have the group link, send a WhatsApp message to this number, both like the new students who are mentioned as new students, and get the Telegram group of the class, and they will send you the details how you can get the tunes couriered. For now, you can get the PDF and continue the work. Okay. So first find the vector A, E and AF. Okay. So then I told you, now look at this in this question, they have asked you to find the 2 vectors AF and AE. Okay, so they have asked it. So what did I mention last week? like what we have to do here is we need to build a relationship between PQ and these unknown terms. Because we know if you can write a relationship between P and Q vectors and the unknown terms, then you can bring the expression to a format of alpha A plus beta B equals 0. ඒක තමයි කරන්න ඕනේ. මොකද්ද කරන්න ඕනේ? මේකේ ඔය PQ කියන දෙන්න ඒ දෙන්න පාවිච්චි කරලා ඔයා ඉක්වේෂන් එකක් ලියන්න ඕනේ. එතකොට ඒ ඉක්වේෂන් එක ගේන්න පුළුවන් අර alpha A plus beta B කියන ඒ format එකට. So that is what you have to do. Now look at this, how we are going to combine these two vectors. We got vector AF and we got vector AE. Now look at this. We got vector AF and we got vector AE. Let's say we only have this vector AF and BF. Then I can apply vector addition to this triangle ABF. But we need to understand that in this one, it is not practical to apply the vector addition. Like some might say, so we know AF and even I know BF. So why can't I apply vector addition to combine the two vectors AF and BF? We need to understand that how did we take this answer is using the vector addition in the triangle ABF. So you have already applied the vector addition to the triangle ABF. So then if you're going to again apply that AF is equal to AB plus BF, you will be getting the result that 0 is equal to 0. What did I mention? Look at this. Let's say you are solving this equation. X plus 2 equals 0. That means x equals minus 2. And now if you take this x equals minus 2 and use that answer in this equation, when you use this answer in this equation, what do you get? What do you get? Minus 2 plus 2 equals 0. You get 0 equals 0. So you have already used the vector addition for triangle ABF to get this answer. Okay, now let's see, because the most common method under this theory was that you were using the vector addition. Okay, now what I'm doing here, I have already got this answer. Now I'm again applying vector addition in this triangle. I'm writing that AF is equal to AB, AF is equal to AB plus BF. Okay, what is AF? That is 1 minus lambda P plus lambda Q is equal to AB is P and BF is lambda BD. P minus lambda P plus lambda Q is equal to P plus lambda, what is BD? Okay, BD is minus P plus Q. Okay, so here you get P minus lambda P plus lambda Q is equal to P minus lambda P plus lambda Q. Which means this cancel off, this cancel off, and this cancel off. You get 0 equals 0. You get 0 equals 0. So why did I end up with this result? I have used the vector addition to get the result, and again I'm using the same result inside vector addition. So when you use one equation to get a result, and when you substitute that answer again to the same result, you end up with 0 equals 0. The simplest example is what I mentioned. If x plus 2 equals 0, we know that x equals minus 2. So we are using this equation to get the answer x equals minus 2. And when you take this answer and substitute into this one, you will be ending up with 0 equals 0. So there's no use of applying vector addition to triangle ABF because we have already used it. Is it clear? Hands up if that part is clear. Okay, so what is the problem that I have? I can't apply vector addition to triangle ABF. So I need to build a relationship between the two vectors AF and AE. I need to build a relationship between the two vectors AE and AF. Now look at this diagram. Tell me what can you say about vector AF and vector AE? Vector AF and vector AE. What can you say about those two vectors? The two vectors are parallel. The two vectors are parallel. Which means I can write this in this way. AF is parallel to AE. Which means I can write that AF is equal to mu times AF, AE. Here comes the story. So far, we only have one unknown term lambda. Last week, in a red pen that we have written the book, if you're going to apply this theory, there should be two unknown terms for sure. So far, I have only had this lambda. Okay, through this one, I'm bringing this second constant, the mu, the unknown term, to the problem. Okay, now I can combine these two. AF is 1 minus lambda P plus lambda Q is equal to mu times AE. What is AE? 5 over 6P plus 1 over 3Q. 5 over 6P plus 1 over 3Q. So this is how you can build the relationship between the two vectors and two unknown terms. So when you take all the terms to one side, you get the result P minus lambda P plus lambda Q a minus 5 mu over 6P minus mu over 3Q is equal to 0. So you get the answer 1 minus lambda minus 5 mu over 6P plus lambda minus mu over 3Q is equal to 0. Okay, so I'm not going to simplify because this is a homework question. You can make this equal to 0, this equal to 0 and get the answer of lambda. Clear? Okay, so that is how I brought another unknown term into the question because I told you there should be two unknown terms and we can solve the problem in this way. Okay, do the work, complete the work. I'll just simplify because this is a small thing. Equals, and then lambda, mu equals 3 lambda. 6 equals 0. I get lambda plus 5 mu over 6. And what is mu? It's 3 lambda. 2 lambda plus 5 lambda over 2. Then I get the answer that lambda is equal to 2 over 7. Lambda equals 2 over 7. Hands up who got the answer. Lambda equals 2 over 7 at home. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, hands up who tried the question at home. Okay, good. Okay, complete the work. So everyone have tried, but only 10 have been able to get the answer. Good, at least you tried it, no? So after next week, I'll be doing a mixed exercise of Victor. So if you have any problems in the homework questions I have given, you can simply even ask me after the class or you can ask during that session. Okay? Better to ask physically in person after the class or you can ask during that session. After next week's completion of the vectors, as usual, we will be doing an additional extra session for these mixed exercises. You can either ask during that session or you can ask me during after the class. Complete the work, get the answer that lambda equals 2 over 7. Okay, write the topic, main topic, unit vector. Unit vectors. Write the main topic, unit vectors. Unit vectors. Unit vectors. Okay. Now silence, listen. A nice concept and like nowadays A-level questions frequently asked based on these unit vectors. The meaning is simple, but the concept is like you need to understand the concept very well If not, you won't be able to apply it in a question. The meaning is simple. So what is a unit vector? A unit vector is a vector to any direction. It can be to any direction, but the magnitude should be 1. The magnitude should be 1. We know a vector consists of a direction and a magnitude. So when it is a unit means to 1. So out of the direction and magnitude, what can be 1? Only thing that can be magnitude is the magnitude that can be 1. A direction can't be 1. A direction can be 1. Have you heard about this human clock? Like let's say you are talking with someone. You are talking with someone. मैं කතා කරනවා කියන්නකෝ. You see someone in this direction. You see someone in this direction. Let's say that direction, if you are facing, like let's say directly, what you see is 12 o'clock. Then you have 1, 2, 3, 4, 5, 6, 7, 8 going in that direction. So I'm here. Now I'm here. And there's a person in front of me. He sees someone, let's say he sees a girl who is sitting or standing in this direction. And he want to say me to look at that direction. If it is the right direction, he can say me, "Dakuna balapang." Look at your right. Okay, I can look at this right. And then if it is the left direction, he can say me, okay, look at the left. But let's say that girl is sitting or standing according to this clock somewhere around the 7 o'clock or 8 o'clock. Then he can say, look at your southwest direction. Can't do that. No. Okay, so what we do, I think even you use that. Or we say, look at your 7 o'clock. Have heard about it? Look at your 7. So then I know, okay, this is 12. Then I don't go in this way to look at 7. I know if that is 12. Okay, this is 7. Then I look in this way. Shape. So in that way, you can say that 1 is even a direction. So if you take 12 as the north or the direction of person, then 1 is this direction. But in general, we know 1 is not a direction. So when it is unit, only the magnitude can be 1. So what is a unit vector? A vector where the magnitude is equal to 1. So if I say that u is a unit vector, the magnitude of u is equal to 1. A simple meaning. The magnitude of u is equal to 1. Clear? Okay, then write in this way. Unit vectors, then write in this way. A vector with a magnitude of 1, a vector with a magnitude of 1 is known as a unit vector. Is known as a unit vector. Is known as a unit vector. Okay, then just draw this and write u is a unit vector. U is a unit vector. U is a unit vector. Okay. And now let's say that I need to, wait. Now let's say we are having this vector A. We are having this vector A. And I need to find the unit vector to the direction of vector A. I need to find the unit vector to the direction of vector A. Now look at this. What I'm going to write is that we have this vector A. No? And I'm taking the unit vector to the direction of A as U. Okay. Unit vector, let U be the unit vector. Let U be the unit vector to the direction of A. To the direction of A. You know, look at this. I'm writing that U is equal to A. So what I want to get is this, we have this vector A, and I need to find the unit vector to the direction of vector A. So if I write this u is equal to A, it's 50% correct because I know a vector consists of a direction and a magnitude. A vector consists of a direction and a magnitude, and out of those two, the direction of these two vectors are equal. Both the vectors are having the same direction. So here, if I write that u is equal to A, that is 50% correct. Why is it 50% correct? Because the direction is correct. Direction, I admit, that is correct. But we know the magnitude is not the same. The magnitude is not the same. Because the magnitude of u should be 1 and A is having a separate magnitude of modulus A. Okay, now think in this way. If I want to convert these two into 1, I want to make this magnitude 2 equal to 1, what can I do? You can subtract 1. Okay, I admit. That's true. You can subtract 1. Let's find to have a common one. I need to convert this magnitude 3 into 1. Then even you can subtract 2. That's correct, I admit. But tell me a common way that how you can convert these 2 into 1, this 3 into 1. What can we do? We can divide this by 2. So when you divide 2 by 2, you get 1. When you divide 3 by 3, you get 1. So based on that, this vector A is having a magnitude of A. No. This vector A is having a magnitude of modulus A. So if I want to make this equal to 1, if I want to make this magnitude equal to 1, what can I do? I can divide this vector by modulus A, because then the direction is anyways the same direction, and the magnitude of this one has been divided by the same magnitude, which means the entire magnitude becomes 1. Clear? Here it's like 2 has been divided by 2. 3 has been divided by 3. මොකද්ද මට මේකේ කරන්න ඕනේ උනේ මෙන්න මේ A කියන එක්කෙනාගේ මැග්නිටියුඩ් එක එක කරන්න ඕනේ. A කියන එක්කෙනාගේ මැග්නිටියුඩ් එක එක කරන්න මම ඒක එයාගේ මැග්නිටියුඩ් එකෙන් බෙදනවා. මොකද මැග්නිටියුඩ් එකෙන් same බෙදුවට පස්සේ අපිට එන්නේ 1. So when we divide this vector A by its same magnitude A or modulus A, we get the modulus or the magnitude of 1. A small thing is like a simple thing, but you need to understand this properly. If not, you won't be able to apply this unit vector theory in a problem. Clear? So let's keep things simple. The vector to the direction of vector A can be written as the unit vector. U be the unit vector to the direction of vector A is equal to A over modulus A. Okay, then draw these two and write this, and we can put this inside a box. Let U be the unit vector to the direction of A. So U is equal to A divided by modulus A. I think, sir, do we have an exam next week? Yes, you're having the main paper 3. I'll give details later during the class. Next week we are having the paper. So everyone should write it, because most probably you will be having a term test after the vacation is over. Most of the schools are having their first term test in December. So it's better to write the paper before you face the term test. Because after the term test, anyways, you will write in every paper in the class. You won't be missing any of the papers after your school term test, especially after you get marks. So before the term test, better write this one and go to the exam. එතනින් පස්සේ කොහොමත් ලියන ඉස්කෝලේ term test එකෙන් පස්සේ. Okay, so we have the vector u be the unit vector to the direction of A. Okay, then writing this way in a normal pen. Hence it is clear that hence it is clear that to find the unit vector to find the unit vector to the direction of a given vector. To the direction of the given vector. Direction of the given vector. We need to divide the vector. We need to divide the vector by its magnitude. By its magnitude. By its magnitude. Okay, then tell me this one. We have this vector OA. We have this vector OA. And the unit vector to this direction is u. The unit vector to this direction is u. Okay, so here I know the modulus of this vector is vector OA. Then look at this. The unit vector to this direction is equal to vector OA divided by its magnitude. Which means you can write any vector in terms of the magnitude of the vector and the unit vector to that direction. You can write any vector. It's clear that you can write any vector. I'll just keep this in terms of A, then it is clear. Then U, this is modulus A. The length is modulus A. So U, I know it's equal to, wait, I'll give it here straight away. So this one is clear that vector A is equal to modulus A into U, which means you can write any vector in terms of its magnitude and the unit vector to that direction. In terms of its magnitude and the unit vector to that direction. So let's take a practical example. So here I'm taking that the length of this line segment is 2. Length of the line segment is equal to 2. Which means the magnitude of vector OA is equal to 2. Okay, now you tell me, now look at this. The unit vector to this direction is u and the magnitude of OA is equal to 2. Then how can I write vector OA? How can I write vector OA? The unit vector to this direction is u. The magnitude of this vector is 2. Look at this. Any vector can be written as in terms of its magnitude and the unit vector to this direction. So now you tell me, if we have this vector u to this direction, and we know that the magnitude of this direction is, this vector is 2, how can I write this vector OA? How can I write vector OA? Equal to 2u. අම්බ ගෙඩියක ගාන 20යි නම් අම්බ ගෙඩි දෙකක ගාන කීයද? අම්බ ගෙඩියක ගාන 20යි නම් if one mango is 20 rupees, how much is 2 mangoes? 40. So how did you get 40? 2 into 20. 2 into the price of one mango. So here the magnitude is 2. The unit vector, the price of 1. The unit vector is u. Then you can write these vectors 2u. Clear? So when we have the unit vector u, then it's clear that vector OA is equal to 2u. Okay, in that case, tell me, same thing. I have another vector, let's say it's BC. The length of this line segment is equal to B. Length of this line segment is equal to B. So length means this magnitude of vector BC is equal to B. Okay, now tell me, everyone. Hey, good, really good. Okay, look at the board. So everyone should answer this. Okay. So everyone should answer this. How can we write this vector BC? The unit vector to this direction is unit vector to this direction. I'll take it as A. Okay, the unit vector to this direction is A. The magnitude of this line segment is B. Then how can you write vector BC? Everyone, how can you write vector BC? B A, not BU. It's not U here. It's B into A. So magnitude into the unit vector. A magnitude into the unit vector. Okay, hands up if that part is clear. Okay, so you better do the next question when I do it, when I give it. Okay, then write in this way after this one. So this is clear to everyone, right? So after this one, first write this, that A is equal to modulus A times U. A is equal to modulus A into U. What is U here? The unit vector. What is A? The magnitude of the vector. Okay, write in this way. Any vector can be expressed. Any vector can be expressed in terms of its magnitude. In terms of its magnitude. In term of its magnitude. And the unit vector. And the unit vector to the same direction in terms of its magnitude and the unit vector to the same direction. To the same direction. Okay, then write these two examples. Okay, so write down these two examples and start the 2024 question. Do the first two lines of the question. You can't do the entire question. After this, start the 2024. Last question in the past paper. Question set. Do the first two questions. Do the first two questions. Two 2024. Silence, silence. I need you to show that OD is equal to the given answer. Only that part. No silence. Just draw the diagram and do it. 2024. Wait, there is a small. Is a two A's should not be underlined here. OA. It should be equal to A, just the distance. It should not be underlined. When this distance, it's 2A. So those are the distance of the line segment. It's not underlined. It's not underlined. It's just the distance of two line segments. Okay, so here the concept is this. Now look at this. They have given the two unit vectors in this direction as U and V. Not the two vectors, the two unit vectors to the direction of OA and OC has been given as U and V. Okay, now tell me, look at the board. If the unit vector to this direction is U and the magnitude of this vector is A, then what is this vector? What is this vector? A, U. The vector is A, U. What is this vector? What is this vector? 2A, B. And you're supposed to find the vector OD. You're supposed to find vector OD. Let's mark it here. You're supposed to find the vector OD. Okay, so this is 2AV. Then I know if this is AU parallelogram, even this vector is vector AU, then you can write OD is equal to OC plus OD is equal to OC plus CD. OC is to AB and CD is half of CB, half of CB, which means CB is the same vector AU, half AU. Small concept, but this was the first time that unit vectors has been tested in this way. Because every time, every past paper question, they directly give you OA is equal to vector A and OC or OB is equal to vector B. So they directly give the vector. And this was the first time that they have given the magnitude and the unit vector. So we need to consider these vectors vector AU. And the interesting part is out of the students who have started this question, who have done the second part of this question. So there are two parts now. Question number 14a is vectors, B is coplanar forces. The lesson we are going to start on, in January. So question number 14 is coplanar forces and vectors. So out of the students who have write this question, only 27 has been able to write this vector OD. Because this was the first time that they have given a length and a unit vector. So we need to take this as AU. Because I just look at the paper soon after the vectors paper, like when students come to the class, by then I didn't see the paper. Like I didn't see the paper means I didn't go through the paper. Just when I look at the applied paper, I just roughly read the paper. Okay, if there are any new parts, I just mark them. If not, like if those are the questions quite similar to the papers or questions we have done in the classroom, I just have understanding, okay, this we have done. And then students come after A-levels, they come and talk about what to do, whether to do a second shy or during this vacation period, they get the after A-level vacation period, what are the good courses, like normally students come. And when just students came and talked with me, I realized like out of, let's say, if 100 students come, around 40% were telling the vectors question, I didn't understand that properly during the exam. Because of that, when I went home, then I just went through the question, and then only I realized that the thing that students were not able to understand properly is if they know the magnitude and the unit vector, they haven't got the idea to write the vector during the exam. Because this was the first time in A levels that you have got a question where the magnitude and the unit vectors has been given. But now you know it clearly. Small thing, when you know the magnitude and a unit vector, you can write the vector to that direction. Clear? No? Hands up who got this and got it? No? Okay, good. So only that part you can do. And if someone asks why they have given the angle, that is for the last part of the question. They have given this angle. Okay, then write the subtopic. We are still under unit vectors. Write the subtopic I and J vectors. Simple I, simple J vectors. Simple I, simple J vectors. Simple I and simple J vectors. Okay. So what are these I and J vectors? I is a standard notation to the unit vector to the horizontal direction. I is the standard notation to the standard notation of the unit vector to the horizontal direction, and J is the standard notation to the unit vector to the vertical direction. So these are unit vectors. No? So when these are unit vectors, what can you say about modulus I? Unit vectors, what can you say about here? This is made. Luckily I saw it. This is not U, this is modulus U. U is not equal to 1, the modulus should be equal to 1. So make that change here, it should be modulus U equals 1. Huh? Not U equals 1, it should be modulus U equals 1. Okay. Okay, then come to here. So what can you say if I is a unit vector? What can you say about modulus I? Tell me, சொல்லுங்க கதா கரண்ட. It's equal to 1. Modulus J? it's even equal to 1. The reason, because I and j are unit vectors, the magnitudes are equal to 1. And you can just write I in this way. You don't have to write I as a worm that I'm just used to write I in that way because of this iota in complex numbers and all. So that's why I'm just writing I as a worm, but you can just put I, not that, this. Okay, what is this? Exclamation mark. We are not doing English, we are doing maths. What is this? Just 1 week, no? What is this? The factorial. The factorial, not the explanation mark. We are not doing English no Sinhala, no. Oh my God. Okay. Okay, I and j unit vectors. Write in this way. Write in this way. The unit vector. Wait, the unit vectors. The unit vectors. The unit vectors to the horizontal and vertical directions to the horizontal and vertical directions are denoted by write in red pen I and j. Only write I j using a red pen, not and. I and j. So write the two letters I and j using a red pen are denoted by I and j respectively. I and j respectively. Okay, then show these two vectors and modulus I, modulus j, both are equal to 1. Modulus I and modulus j both are equal to 1. Okay, so why is this important? Look at this. Now, if we say that we are having this coordinate plane, we have y here and we have x. Now, look at this. We have y here and we have x. And the unit vector to this direction, it's I. And the unit vector to this direction, it's j. Okay. Now, look at this. We have a point A with the coordinates 2 and 3. With the coordinates 2 and 3. Which means the x value here is 2 and the y value here is 3. And I need to write the position vector of A, which is OA. I need to write vector OA. So it's clear according to this diagram, how can I write this OA? You can consider this vector and plus this vector. So how can you write OA, this vector plus this vector? So what is this vector? Now tell me, what is the magnitude of this vector? Tell me, what is the... Nidine. Listen, killing, keep your back straight. කොහොමත් කාලයකදී නැවෙනවා මගේ පොඩ්ඩ පොඩ්ඩ දැන් නැවෙනවා. ඔය කාලේ ඉන්නෝනේ කෙලින් ඈ. මු ගෙදර. Okay, what is the magnitude of this vector? It's 2. What is the unit vector to that direction? Hi, පෙන්නනේ කියන්න තියෙන පොඩි දෙයක්. What is the magnitude of this vector? 2. What is the unit vector to that direction? I. So then what is this vector? It's 2y. Nice. What is the magnitude of this vector? 3. What is the unit vector to this direction? J. So this vector is 3j. So then when you know the coordinates of that point, you can write this vector, the position vector of OA, it's equal to 2i plus 3j. You can write the position vector of any point on the Cartesian plane in terms of I and j. Let's say that we are having the point B here, the point B here. It's minus 2, 2. It's minus 2, 2. So I need to get the position vector of B Now I'm going to use this way. I'm going to consider this vector plus this vector. Okay, so here we have minus 2. No? Tell me, what is the magnitude of this vector? What is the magnitude of this vector? Minus 2. It's 2. There can't be a negative magnitude. Can the weight කොච්චර කෙට්ටුනත් බර වෙන්න පුළුවන්ද ඍණ 10යි. බර කීය? කිලෝ ඍණ 10යි. No. How less it can be? It can be negative because it's a numerical value. So the modulus or the magnitude here is 2. But now tell me, what is the unit vector to this direction? It's not I. What is I? I is the unit vector to this direction. So what is the unit vector to this direction? It's minus I. That's how you get the minus 2 vector, 2I. So how did this become minus 2? It's the module, the magnitude is 2. The unit vector is minus I because we know it's opposite vector. So that's how you get minus 2I. Here, same story. This is 2J and this is 2J. So you can write the position vector of B, it's equal to minus 2I plus 2J plus 2J. Okay, one more. Let's say we are having point C here. It's 4 and it is point C. Point C. So I need to write the position vector of C, which is directly this vector OC, which is directly this vector OC. So tell me, the magnitude of this one is J4. The unit vector to this direction is J. So how can you directly write OC? How can you directly write OC? It's J, 4J. OC can be directly write. We don't need a I because to write a vertical vector, you don't need any I. You can directly go. What is that? That's 4J. 4J. Let's write one more point. I'm having 3 here. The point is D. So tell me, what can you say about vector OD? Tell me, speak. What can you say about vector OD? 3I. You don't need the support of J. A vector OD is equal, the magnitude is 3. The unit vector is I. So that is equal to 3I. So it's clear that vertical vectors can be written in terms of J. Horizontal vectors can be written in terms of I. Okay, so we have written this one. Then write in this way. Using ij vectors, the position vectors of any point, the position vectors of any point on the Cartesian plane, can be expressed in terms of I and J. Wait. How? Yeah. So you have to have a sense when you're writing it. I have started this sentence by using ij vectors. So the line should be ending by can be expressed. Using ij vectors, the position vector of any point on the Cartesian plane can be expressed in the following manner. Whatever I say, you need to focus, pay attention. Okay, can be expressed in the following manner. Okay, then write this and draw this diagram and write these 4 vectors. So the line should be ended by can be expressed in the following manner. That's all. Can be expressed in the following manner. Draw the diagram and consider this data. Silence, silence. Do the work. Silence, just draw this and understand what we have written here and taken this. So then shouldn't the second, no, the second equation was correct. That is vector u is equal to vector a divided by vector modulus a. That is correct. Silence. Stop talking while writing this. Don't just copy paste the board. Try to understand every small detail and write down what I have given. Okay, then start question number 19. And question number silence. Question number 19. No, silence, silence. We're talking to question number 19 in the tute. Okay. Okay, so before coming to question number 19, now look at this. Look at the board. Okay, so here we have taken this in this way. So then in general, you can consider, look at this. Silence. Now listen to this. Look at the board. In general, I'm taking a point on the Cartesian plane to be xy. Okay, listen, listen, listen. දහලා මේක කරන්න මේක ඕනේ. Listen. Okay. So then I have the two vectors. This I'll take this x and y, the two axes, and then I know the unit vector to this direction to be I and j. So I have taken a point in general, x and y. Then it is clear, you can write this vector OP is equal to xi plus yj. Is equal to xi plus yj. And let's say that I want the modulus of this vector, which means the length of this vector. I need the modulus of this vector, which is the length. So how can you take the modulus or the magnitude? Using the Pythagoras theorem, you can easily get this magnitude. What is that? X squared plus y squared, square root. No? So you can get the magnitude OP. This is equal to x squared plus y squared, square root. And if you want to find the direction, normally if they ask the direction, you can take this angle to be theta. And then you can write the direction in this way. You can write the direction, it's tan theta is equal to y over x. Tan theta is equal to y over x. Which means for now, just keep this in this way because we haven't done inverse trigonometric functions yet. For now, just keep the answer in this way that theta is equal to tan inverse y over x. You can use this one. What is the magnitude when the direction, when the vector is in terms of x and I and j? The coefficient of I squared plus the coefficient of y, j squared square root, and the magnitude, the direction is this y over x, the tan inverse of that. Okay. Okay, then you can write this in general, then draw this diagram and get the magnitude and the direction. So now any talking, first write in general, write down this and then do question number 19. First write down this and then do question number 19. Okay, question number 19. The position vector of A, which means OA, has been given 8i plus 6j. The first one is find the magnitude. Okay, what is the magnitude? We know the magnitude is the square of the coefficient of I plus the square of the coefficient of j, which gives you 64 plus 36 root the modulus. This is equal to 100, which means 10. So if you can directly write 10 after this step, that is okay, because you only get marks for writing this and this. So if you can bypass the simplification steps and directly write 10, much better, you will be getting the total marks. A second one, find the unit vector in the direction of OA. Okay, now tell me, if you want to get a unit vector to the direction of a given vector, if you want to find the unit vector of a vector to a given direction or a given vector, what should you do? You have to divide that vector by its magnitude, by its magnitude. So write it, let u be the unit vector, u be a unit vector to the direction of OA. Let u be the unit vector to the direction of OA. So what did we learn? If you know the vector OA, the unit vector can be obtained by dividing the vector OA by its magnitude. So this is 8i plus 6j over the magnitude is 10. So when you divide it separately, it's 8 over 10i plus 6 over 10j, which means this is equal to 4 over 5i plus 3 over 5j. This is equal to 4 over 5i and 3 over 5j. Unit vector. Third one, find the angle that OA makes with the x-axis. I told you to get the angle directly. How can you take the angle? Tan theta is equal to y over x. In this case, it's 6 over 8. So tan theta is equal to 3 over 4. So just keep the answer theta. Even though we haven't done this inverse trigonometry in this way, tan inverse 3 over 4. Last one, find the vector that is 5 units to the direction of OA. Okay, now look at this, look at the flow. This is vector OA. What is the magnitude? 10. What is U? U is the unit vector to the direction of OA. So now you tell me, if U is the unit vector to the direction of OA, how can we write the vector with a magnitude of 5 to the direction of OA? How can we write the vector with a magnitude of 5 to the direction of OA? 5 U. If the price of one mango is 20, how can we take the price of 5 mangoes? We have to multiply by 5. Simple thing. So here, the unit vector is U. So the required vector, the vector with a magnitude of 5, vector with a magnitude of 5 is equal to 5u. If you know the unit vector, you can easily find any vector. Same as if you know the price of one mango, you can find the price of any number of mangoes, no? Okay, then it is 5 times 4 over 5i plus 3 over 5j. When you multiply 5 cancel off, it's 4i plus 3j. It's 4i plus 3j. Okay, hands up if this is clear. This is clear. Okay, then I need to see everyone doing question number 20 and you need to do it correctly. Complete this and do the next question, question number 20. And if you have any questions, even online students, you can ask in the chat. You can ask it when I come near to you, you can ask the question. Question number 20, the coordinates have been given as 9 and 12. The coordinates of M is 9 and 12, which means vector OM is 9i plus 12j. The magnitude is 9 squared plus 12 squared, which gives you 15. You can either write 15 directly or you can show the simplification. You get 225. So vector OM is equal to 50. And they are not asking you to find the unit vector. They are directly asking you to find the vector with a magnitude of 10. So same thing, if you know the total of 3 mangoes, and if I ask you what is the total of 5 mangoes, let's say the total of 3 mangoes is 60. We bought many mangoes. No, the total of 3 apples, it's 60. So what is the total of 5 apples? The total of 3 apples is 60. So then what is the total of 5 apples? You need to find the roots of a quadratic equation to get that answer. It's 100. So how did you get 100? If the price of 3 apples is 60, the price of 1 apple is 20. So then the price of 5 apples is 100. 5 into 20. Same thing. So you can't directly find the vector with a magnitude of 10. First find the unit vector. So I'm taking the unit vector as u. A unit vector is u, that is equal to OM divided by its magnitude. OM divided by its magnitude. Then this is equal to 9i plus 12j divided by OM magnitude is 15. So when you separate, divide it, 9 over 15i plus 12 over 15j, which gives you, this is 3 over 5i plus 4 over 5j. So, but this is u. They're not asking u. No? So, you know when the unit vector is u, the vector with a magnitude 10 is 10u. Vector with a magnitude 10, that is equal to 10u. That is equal to 10u. Which means 10 into this, 3 over 5i plus silence. So when you multiply, 2 is remaining, 6i plus 8j. Okay, hands up who got 15, 9i plus 12j, and last one, 6i plus 8j. Okay, do the next one, 21st one. Okay, so we have the two coordinates A and B given 1, 2, 2 minus 3. 1, 2, and 2 minus 3. Question number 21. A is 1, 2, and B is 2 minus 3. First find OA, it's vector I plus 2j, and OB, it's vector 2i minus 3j. And then AB, how can we write vector OAB using the addition of position vectors what we have learned before? So vector AB is equal to OB minus OA. OB minus OA. OB is 2i minus 3j. If anyone is having a doubt, how did I write this one? That is, I told you when the vectors are in terms of position vectors, you can write the vector addition the position vector of the right side one minus the left side one. So OB minus OA. What is OA? It's I plus 2j. Okay, then we have 2I minus 3j minus I minus 2j, which means vector AB is equal to I minus 5j. I minus 5j. Then the magnitude of AB, the magnitude is equal to 1 squared plus minus 5 squared square root. So there's no use of taking the minus because here the coefficient is 1 and it's minus 5 because I know when it squares, I'm ending up with the same positive ones. So the magnitude of AB is equal to root 26. Last one, take the unit vector to the direction of AB as u. The unit vector, I'll take it as u. Then u can be written as vector AB divided by its magnitude. Okay, then u is equal to I minus 5j over root 26, which is 1 over root 26, I minus 5 over root 26, j. One over root 26 I minus 5 over root 26j. Okay, got the answers. Okay, then do the next one, 22. So if we keep the answers in terms of roots, is it all right in the exam? Yeah, in A level, these root answers and fractional answers are accepted as final answers. Because even in this one, you don't have to convert them into decimals. Not like in O levels, in A levels, keeping the final answer in terms of root, like root means root 4 is equal to 2, but if it is not a proper root, you can keep the final answer as roots, and even the fractional format is accepted. Okay, so this is like the same way we consider the vector addition. Okay, now look at the board. So this one is the same way that we considered vector addition in the first day, since the first day. So we have two vectors, OA and OB. Okay, and they have given in terms of the ij notation, ij unit vectors. So vector OA is 2I plus j, and vector OB is equal to I minus 3j. So these are the two vectors. No? And then point C has been, yeah, point C lies on AB such that AC to CB is equal to 2 is to 1. So we have C here and we are supposed to find the position vector of C, which is OC. It's 2 is to 1. The ratio is given as 2 is to 1, AC to CB. Okay. Then the same thing, how can I write OC using vector addition? That is, I'll go in this way, OA plus AC. And what is OA? OA is 2I plus J. And AC, I know if the entire one is 3, AC have 2 units. So that is 2/3 of AB. 2/3 of AB. And then what is AB? AB can be written in the same way we have taken this, OB minus OA. Clear? Same thing, the vector addition. OC is equal to, you can even go in this way. I have taken this root, OA plus AC. And then this is equal to, what is OB? It's I minus 3j I minus 3j minus 2I plus j minus 2I plus j. So then we have I minus 3j minus 2I minus j. Okay. So if you take out this 1 over 3, this becomes 6I plus 3j, 6I plus 3j, plus 2 times this is minus I minus 4j. So when you simplify further, I get minus 2I minus 8j. So I have got this answer. What is vector OC? OC is equal to 1 over 3, 4I minus 5j. 4I minus 5j. You can either keep 1 over 3 out or you can multiply and keep this as 4 over 3 minus 5 over 3. This is what you got. Okay. Okay. Hands up who got this vector OC 1 over 3, 4I minus 5j. Better. Okay, then look at the next question, question number 23. Think of a way how you can do the first question. So I'll give you 2-3 minutes and I'll explain. Question number 23. Read the question, sub question 1, and think of a way that how you can do this. Question number 23, sub question 1. So this one, don't just copy paste. If you didn't get the answer after this one, do the simplification alone. Because today is the 4th day of vectors and you are not any more kids in A levels. You have been here for more than 8 months. You have worked with combined maths. So you are not kids in combined maths or A levels. If you didn't get the answer, be responsible. Find out or figure out where did you go wrong. And then from that point onwards, do the work alone. If not, you won't learn at all. Because you are not here to copy paste the boards. No. Okay, try the 23rd one. First question. Okay, now look at this. The two vectors are 2I minus j, I minus j. Okay, so now look at this. The two vectors is 2I minus j and I minus j. So they are talking about this vector alpha plus lambda b, and they have given that this vector is parallel to the direction, parallel to vector I. Okay, now listen, look at the board. So we have this a plus lambda b vector. No? So what is a? It's 2I minus j. A lambda, what is b? I minus j. So first thing, like when you have this I and j in separate places, it's hard to apply any of the theories because you can remember, even in this alpha a plus beta b equals 0, first thing we need to do is bring these vectors a, b to one place. Bring the vector a to one place and vector b to the same place. Okay, so first thing is I'm going to write I, it's lambda plus 2 times I. If you take out this minus lambda plus 1 j. So this is vector a plus lambda b. So they have given that this vector is parallel to the direction of vector I. No? So what is vector I? What is vector I? It's the horizontal unit vector. So when they have given this vector is parallel to this vector I, that means even this vector is a horizontal vector. So this vector a plus lambda b is horizontal. So can you remember when we have a horizontal vector, that horizontal vector can be written only in terms of I. Look at the board, look at the first page, look at the first page of IJ vectors. First page of ij vectors, not vectors, ij vectors. So here, Mark, you can see this horizontal vector can be written only by using I. Similarly, the vertical vector can be written only by using j. The vertical vector can be written only by using j, which means this is a horizontal vector. So it can be written only using I, which means I don't want this part. There's no any j component here. There's no any j component here, which means the coefficient of j should be equal to 0. There is no any j component, which means the coefficient of j should be 0. Lambda is equal to minus 1. Lambda is equal to minus 1. Clear? Okay, then yeah, come up to this part. Come up to this one, a plus lambda b, and simplify it. Come up to this stage, this. Up to here, then I'll give a small note. Okay, simplify this, and a plus lambda b is equal to lambda plus 2i minus lambda plus 1j. Okay, then write, after that one, write in this way. A plus lambda b is a horizontal vector. A plus lambda b is a horizontal vector. A plus lambda b is a horizontal vector. Therefore, when it is therefore, keep the 3 dots. You know it, no? Therefore, okay. Therefore, it can be only, no wait, it can be expressed. Therefore, it can be expressed only in terms of I. Therefore, it can be expressed only in terms of I. Only in terms of I. Okay, then that means this one should be 0. Okay, make this 0 and get lambda equals minus 1, and do similarly the second one. The same way, do the second one, question number 23. Second one, do the next one, that mu a plus b is a vertical vector. Okay, then simplify mu a plus b, mu a plus b. So it's mu times 2i minus j plus b. First, rearrange this and write it in a way that I is together and j is together. 2 mu I minus mu j plus I minus j. So then I have 2 mu plus 1 times I minus mu plus 1 j. This is mu a plus b. Okay, so this is a vertical one, no? Parallel to vector j means mu b, mu a plus b is vertical. So when it is vertical, it can be only expressed in terms of j. Therefore, this component I should be 0. Then I get 2 mu plus 1 is equal to 0. Mu is equal to minus half. Mu is equal to minus half. Okay. Okay, I'll give you 1 minute. Drink some water. If there's anything, you can talk. I'll give a proper interval wait after like 10-15 minutes. For now, drink some water. Water take up. Take a make good up. You are getting interval. Okay, so the next. Okay, silence, silence, silence. You know, look at the board. Okay, so the next main topic that we need to discuss is the product between 100, product between two vectors over the vector product. So before moving on to that one, there is a small part we need to learn. Write a small subtopic. Angle between two vectors. Angle between two vectors. Angle between two vectors. Okay. So what is the angle between two vectors? Is, let's say, two instances. Either the two vectors should be diverging away from the same point. So here you can see, look at the arrows, the two vectors are diverging away from the same point. Or the two vectors are converging to the same point. The two vectors are, these are stuff that you have learned in physics, no? So that's why doing physics is compulsory when you're doing combined math. It's not compulsory. I don't know whether you know it, and there is another subject that you can do instead of physics, which is we call it higher maths or double maths, not double maths. I think higher maths, where we have this the comprehensively it will be pure maths, not O-level maths. But I think in a given year, normally around even less than 20 students are doing that subject. I can't remember whether it is now. Don't go make the switch to physics from that one. I can't remember whether it is higher maths or double maths. Anyone who know that what is the subject? Further maths. So further maths goes with higher maths, no? So maybe higher maths, no? Okay. Now listen. Hey, look at the board. Huh? More maths, the double maths. Okay. Focus. Look at the board. So like more, forget about that 20, less than 20 students who are doing combined maths. Normally 35 students, 35,000 students do combined maths. Forget about that 20%, 20%. Forget about that 20 students who are doing higher maths. So everyone else are doing physics. So that is the reason that why physics goes with applied maths, because you learn these stuff as the basics of physics. So when the two vectors are diverging away from the same point, or if the two vectors are converging to the same point, we call this angle as the angle between the two vectors. Okay, so here the angle between the two vectors, angle between two vectors, between the two vectors, it's theta. Even in this instance, the angle between the two vectors, it's theta. It's theta. But let's say we are having a diagram like this. Okay, here is one vector and this is one vector. And here the angle is theta. But I know here the two vectors are not even diverging from the same point, not even converging to the same point, because this is converging, this is diverging. So what we do here, we replace this vector to here, which means it is a extended version of this. So when you extend this, it's clear when you replace this vector, you take this vector and place it here. You take this vector and place it here. And then the two vectors are diverging from the same point, but we know the angle is not theta. In this case, the angle is phi minus theta. In this case, the angle is phi minus theta. So in this case, the angle between the two vectors, it's phi minus theta, 180 minus theta. Clear? Because this one is not either converging or diverging. So you replace this by this one. The two vectors are diverging. Small thing. Then just write in this way. Write in this way. The angle between two vectors, the angle between two vectors, when the two vectors are when the two vectors are either diverging from the same point either EITHER, either diverging from the same point or converging towards the same point. Converging towards the same point is considered as the angle between the two vectors. Is considered as the angle between the two vectors. The angle between the two vectors. Okay, then draw these three diagrams. So here it's clear the two vectors are diverging. Here it's diverging. Diverging means going away. Here the two vectors are converging. But in this case, it's not even diverging or even converging. Okay. Okay, then write the main topic, product of vectors. The main topic, product of vectors. Product of vectors. Product of vectors. Okay. You were. So quick, no? Okay. Product of vectors. A big topic. Underline your red pen. Surely use your blue pen. That is okay. But okay, now look at this. So the vector product, there are two types of vector products. There are two types. Vector product can be discussed under two categories. One is the vector dot product. Vector dot product. The other one is the vector cross product. Vector cross product. So vector product is the main. Then here we are discussing about the product between two vectors. Here we are discussing about the product between two vectors. Only two vectors. Two types of vector products. One is vector dot product and the other one is cross product. So being simple, why do we name this as vector dot product? The reason is it is denoted by a dot. It's denoted by a dot, so we call it as dot product. What is there? That means this one is denoted by a cross. A cross B. But we know when it is scalars, even though we write 2 into 3, it's 6. If we write 2 into 3, sometimes we use a dot, no, because we have to specifically mention that this is not 2.3. If we mention this dot, it's the same. And let's say A and B are two scalars, numbers. Even though we write AB, A dot B, A into B or A cross B, all are giving us the same value, no, same meaning. But when it is the vectors, we are getting two different products. Here it's the vector dot product. Here is the vector cross product. The result of the vector dot product is a scalar. The result of the vector dot product, the result of the vector dot product is a scalar quantity, which means it's only a magnitude. But the result of a vector cross product is a vector. So it's clear we are getting two different results, no? When it is two scalars or two magnitudes or constants, simply two numbers, even though we write this in this way, we are getting the same result. Okay, don't sleep. We're getting the same result, AB, A dot B and A cross B. Same result. Nidine, hey. Can't get zoned out inside this class. You can get zoned out in a different class, but not in this class. Zone out means the English word of manopar. I can't say the mental attack. Why you are having a mental attack? No. The manopar. Right? Mano, mental, par, attack. Hmm. When you were there in the morning last week, no? I was a marunane, misunane, yes. Right. There was some other who were in the morning and they have missed in the evening. Good. So here the result is a scalar and the result is a vector. So tell me, why do we call this as the vector dot product? Why do we call this as the vector dot product? Because we denote it by a dot. Why do we call this as a vector cross product? Because it is denoted by a cross. And the result is a scalar. No? Because the result is a scalar, this dot product is even considered as the scalar product of two vectors. Because the result is a scalar, this is even known as the scalar product between two vectors. Because the result is a vector, this product, the dot product, is even known as the vector product of two vectors. Vector product of two vectors, and this one is also known as the scalar product of two vectors. Why do we call this as a scalar product? Because it denoted dot. Okay. Nice. Why do we call this as a scalar product? Because the result is a scalar. Why do we call this as a vector product? Because the result is a vector. Clear. So in our syllabus, we comprehensively discuss about the vector dot product, but we don't get angry here. So we comprehensively discuss about the vector dot product, but we don't discuss about the vector cross product. We are only doing a basic introduction of the vector cross product. Even in the syllabus, they have clearly mentioned giving a basic introduction of vector cross product is enough. They are not expecting us to solve problems using the vector cross product. That is mentioned in the syllabus. So this one will be comprehensively discussed. But this one, there's only a basic understanding to give you an idea what is the cross product. That's all. But we won't be working or solving problems using the cross product between two vectors. Okay. Then product of vectors, and write in this way. Write in this way. The product between two vectors. The product between two vectors can be discussed under two types. Can be discussed under two types. Can be discussed under two types. Okay. Then put this vector product and write the two vector dot product and vector cross product. Any questions here? So write these two. So write this in a proper way. What is this? Could you please upload the modulus graph recording? What do you mean by could you please upload the modulus graph recording? It's already uploaded in the website, no? Yeah, so can you please? Yeah, it's in the website. So we have done modulus graph in October. So that should be in the website because normally we don't take down videos from the website. It's already there. Under the October videos, modulus functions are there. Silence, just write this vector dot product, cross product. So here the result is a scalar. Because of that, we termed it as scalar product. Here the result is a vector. Because of that, we term it as vector product. Okay, then writing this way. In our syllabus, vector dot product in our syllabus, vector dot product, will be discussed comprehensively, will be discussed comprehensively while a basic introduction will be only done for vector cross product. For vector cross product. Okay, take a break and come by 5:55. Okay, so write the next main topic. So here under the product between two vectors, then write the topic vector dot product. Write the topic vector dot product. Okay, no, silence, vector dot product. Okay, so what is the vector dot product? When we have this vector A and vector B, and the angle between the two vectors is theta. We have the vector A and vector B, and the angle between the two vectors is theta. Okay, then the vector dot product is defined in this way. It's modulus A, modulus B, silence, into cos theta. So this is a definition. So even I have mentioned this before, a definition of maths cannot be proved. We can't prove a definition because that has been defined in maths. For example, like what we learn as maths is somewhere that is written in a textbook of maths. There's no any particular textbook, mathematics textbook, but algebra or coordinate geometry, calculus, these that what we learn comes from a particular textbook, which has been written by like some of the mathematicians. So in those textbooks, they have defined some of the terms. Those cannot be proved. So there is no any way that we can prove that A dot B is equal to modulus A, modulus B, cos theta, because that is a definition. So any definition, if you can remember, we did factorial last Monday. In factorial, I told you the factorial of 0, that is equal to 1. That is equal to 1. Even that is a definition. But even if you like, I mentioned about factorial 0. Yeah. Yes or no? Yes. But if you just search like search in YouTube the definition of factorial 0, you might get a proof. Okay. But those are not standard proofs. For example, now look at this. For example, look at this, silence. 2 to the power 0 is equal to 1. You can't prove that. No. You can't prove this because 2 to the power 1 is, you get the idea, 2. 2 squared is 2 into 2 is equal to 4. No? It's equal to 4. 2 cube is equal to 2 into 2 is 8. So you get the idea. No? When there is 3 2's, it's 2 into 2 into 2, it's 8. When it's 2 square, there are 2 2's, it's equal to 4. When it's 2 to the power 1, it's equal to 2. You get the idea. But when it is 2 to the power 0, there's no any 2. No. There's no any 2. Like 2 cube is 3 2's. 2 to the power 2 is 2 2's. This is 1 2. So when it is 2 to the power 0, there's no any 2. But we say that it is equal to 1. That is equal to 1. Okay. So if I ask, like if you search for a YouTube video asking how can I prove this? So there is a way that how you can prove this, but those are not standard proofs. Okay, those are not standard proofs. Hands up, be honest, and hands up who, after going home last Monday, who Googled for proof of factorial 0 equals 1. No one who Googled to search in YouTube. No one. Okay, never mind. Never mind. So that's why, never mind. That's okay. Because if you are interested in maths not being framed into this A-level combined maths syllabus, Because there are some students, good students who are really good in maths, even though they are taking a result that are eligible to go to the University of Moratuwa Faculty of Engineering, they are not going to the engineering faculty. They end up in the Colombo University Physical Science faculty. Because if you are really good in maths, really talented in maths, you should go in this physical science stream. So there are students who are selected to the engineering faculty. They don't go there. They go to University of Colombo, Faculty of this Science, where you do this math special, and they even do their PhD up to that level. So if you are that interested in maths, you can do that. But if you just go home, I'm just mentioning that because I told you there is no any standard definition, standard way to prove factorial 0 is equal to 0 is equal to 1. But if you search that in YouTube or Google, probably you will get 2-3 videos where they have mentioned the proof of factorial 0 is equal to 1. So it is done in this similar way. I told you even this one doesn't make any sense. No? 2 to the power 1 can get idea. 1, 2. 2 to the power 2, 2 2s. 2 to the power 3, 2 to the power 4. You can have idea. But when it is 2 to the power 0, like there's no any 2's, but how did 1 come? So it is explained in this way. So here it's equal to 2, it's equal to 4, equal to 8. So I'll explain in a small way. From here to here, how does 2 to the power 1 becomes 2 to the power 2 when you multiply by 2? How does 2 to the power 2 becomes 2 to the power cube when you multiply by 2? Similarly, how this becomes this when you multiply by 2. So when you multiply by 2, you get this, and you get this. So if I want to go in the reverse, from here to here, what should I do then? What should I do? Divide by 2. So when you divide 8 by 2, you get 4. When you divide 4 by 2, you get 2. When you divide 2 by 2, you get 1. You get 1. So that is one way that you can say 2 to the power 0 is equal to 1. Same thing will be used when we are using the factorial notation. Now look at this. Factorial 1 is equal to 1. Factorial 2 is equal to 1 into 2, which is equal to 2. Factorial 3 is equal to 6. I'll stop from here. Factorial 4 is equal to 24. So these are not standard proofs, just mathematically correct. Okay, from here to here, how do we get this one? It's clear that you have multiplied by 2 to get this one. From this to this, to get factorial 3, from factorial 2 to factorial 3, to get this one from this, tell me we need to multiply this by 3. To get this from this, what is missing? We need to multiply by 4. Okay, then tell me what is factorial 5. It's 1, 2, 3, 4, 5, which is 120. So up to factorial 4, we have these 4. To get this one from here, what can we do? We can multiply by 5. So for coming down from here to here, how do we get this? Multiply by 2, 3, 4, 5. Then it is clear when we go in reverse, go back. To get 120 and it becomes 24, multiply by 5. So here we divide by 5. From 24 to 6, we divide by, multiplied by 4, this divide by 2. Multiplied by 3, divide by 3. Multiplied by 2, divided by 2. Then when I'm coming from here to here, it's the what is missing is the part 1. So here it's clear, we divide by 5, 4, 3, 2, which means when you divide this by 1, 1 divided by 1 becomes 1. So that is just a mathematically correct way to say that factorial 0 is 1. That is not necessary and not related to vectors, but I gave this. If you get the thought of going home and Googling the proof of factorial 0, you don't get that thought. In case if some student get the thought of Googling it. You might get a proof. So that's why I explained. You can do this in that way, but that is not a that is not a standard proof. Those are definitions. Okay, so again, come back to the lesson. So that was a commercial advertisement. Come back to the lesson. So this is a definition. The vector dot product is defined in this way, which means this cannot be proved. So here it's clear. Modulus A is a magnitude. Modulus B is a magnitude. Cos theta magnitudes, no? We get the cos values, half, root 3 over 2, 1 over root 2, 0, 1. These are values, numerical values. So this is a magnitude, this is a magnitude, and even this is a this is a magnitude, a numerical value. So the product of three values gives you a scalar quantity. It's clear. The product of three magnitudes give you a scalar. That's why I told you that the vector dot product is a scalar. Because this is a scalar, this is a scalar, scalar. Product of three scalars give you a scalar itself. Okay. Then vector dot product, write in this way. When the angle between vectors A and B, when the angles between vectors A and B, vectors A and B is theta, is theta, is theta, the vector dot product, the vector dot product is defined in the following manner. Is defined in the following manner. Is defined in the following manner. Okay. Okay, then just draw this diagram and write the definition. Modulus A, modulus B, cos theta. Modulus A, modulus B, and cos theta. Okay. Then write the subtopic beyond the vector dot product. Write this important points related to vector dot product. Important points related to vector dot product. Important points related to vector dot product. Okay. The first thing is in the vector dot product, vector A dot B is equal to B dot A. A dot B is equal to B dot A. Now you might think, so this is quite normal. 2 into 3 is equal to 6 and 3 into 2 is equal to 6. But those are scalars or magnitudes. These are vectors. So this is not quite normal. This is a property of vector product that A dot B is equal to B dot A. Why is this not normal? Because if you consider the cross product, A cross B is not equal to B cross A. So that's why this is given as a property. So we call it as the commutative property. The reason, because when it is the cross product, that is not equal. So you can't say, 2 into 3 is 6, 3 into 2 is even 6. Those are numbers, those are magnitudes. But here we are working with vectors. So in vector dot product, we say that the vector dot product is commutative, which means that our A dot B is equal to B dot A. Because it's clear, when you write A dot B, when you write A dot B, it's modulus A, modulus B, cos theta, and even though when you write B dot A, same story, modulus B, modulus A, cos theta. So it's the same, no? So that's clear that A dot B is equal to B dot A. Okay, so then write the first one, number 1. So we are discussing important points related to vector dot product. Put number 1. The vector dot product vector dot product is commutative. The vector dot product is commutative. And then towards the middle, using a black pen, write A dot B equals B dot A. Using a black pen, write A dot B equals B dot A. A dot B equals B dot A. Okay. Small thing, A dot B equals B dot A. Second one is we say that the vector dot product is distributive. The vector dot product is distributive, which means if we have A dot B plus C, this can be written as A dot B plus A dot C. So this one can be written as A dot B plus A dot C. A dot B, A dot C. Write the second one, small things. Second one, the vector dot product, the vector dot product is distributive. The vector dot product is distributive. And then write this one. A dot B plus C can be expanded as A dot B plus A dot C. Okay. Okay, write the third one. Using a red pen, write this. Using a red pen, write this perpendicular vectors. Using a red pen, write this perpendicular vectors. Okay. So when it is perpendicular, now consider two vectors are perpendicular. Silence, silence. Focus. Two vectors are perpendicular. So when those are perpendicular, the angle between the two vectors here is 5 by 2. Silence again. Focus. The angle between the two vectors are 5 by 2. Hey, look at the board. Hey, look at the board. I'm teaching. I want to teach you. So it's a 5 by 2. So now when you write A dot B, it's equal to modulus A, modulus B, and cos 90. No? What can you say about cos 90? Cos 90? It's 0. Good. 0. 0. So when it is 0, we get A dot B is equal to 0. Which means the dot product between two perpendicular vectors is 0. The dot product between two perpendicular vectors are 0. So let's say you are supposed to show that two vectors are perpendicular. You are supposed to show that two vectors are perpendicular. What can you do? You can consider the dot product between the two vectors and show that it is equal to 0. Because if the dot product between two vectors is 0, that means the two vectors are perpendicular. How can you show that two vectors are parallel to each other? Not perpendicular, parallel to each other. How can you show that? How can you show that two vectors are parallel to each other? By showing that the two vectors are dependent. By showing that, mataka the dependent. Okay. By showing that two vectors are dependent. So if you can show that the two vectors are dependent, which means silence. If you can express one vector in terms of the other vector, you can say it's dependent or dependent vectors are parallel. So that is how you can show two vectors are parallel. This is how you can show two vectors are perpendicular. One of the main theories, and at least 50% of the A-level past paper questions is based on these perpendicular vectors where the dot product is equal to 0. Okay, then right, okay, you have written this to perpendicular vectors. First, then draw this diagram and get that A dot B is equal to 0. Get the result A dot B is equal to 0. A dot B is equal to 0. A dot B is equal to 0. Get the result A dot B is equal to 0. Okay. They're writing this way to show that two vectors, to show that two vectors are perpendicular, are perpendicular. Give me another name for perpendicular. Another name to perpendicular. Have you heard the word orthogonal? No. Okay, so let's learn it for the first time. Then this orthogonal, OR, orthogonal. So that even says that the any two lines are perpendicular. So when we have to show that two vectors are perpendicular within brackets, because you will find that term in questions. මාතන දෝමි ගහන්න හතරක් වුණේ. Sit in a proper way. Don't sit in a diagonal way when you're in the classroom. Just sit facing this way. You don't have to turn in this way to look at the screen. Just turn your neck. So that's why humans got a rotatable neck to turn in this way. You don't have to sit in a diagonal way and look at this. Because then you're always ready to talk with your partner than one next to you. Every time when I look at this, in this direction. No, just sit properly and turn your neck. You turn the neck, no. You know, within brackets, orthogonal, we need to show to show that two vectors are perpendicular within brackets or orthogonal, orthogonal, and then continue. We need to show that the dot product is 0. Dot product is 0. Okay. Then number 4, the one before last one. And number 4, dot product of the same vector. Number 4, dot product of the same vector. Dot product of the same vector. Okay. Dot product of the same vector. Okay, now we have the same vector. We have vector A and the same vector, vector A. Same vector. We have vector A and vector A. Okay, so in this case, if I consider A dot A dot A, it's equal to modulus A cos. Okay, when we are considering the same vector, what is the angle between the same vector? What is the angle between the same vector? It's 0, no? It's 0. So here, theta is 0. Theta is 0. And then we have cos 0. And you know better than me that cos 0 is equal to 1. Which gives you A dot A. If you consider the dot product of the same vector, modulus A into modulus A is modulus A squared. So when you consider the dot product of the same vector, you get that is equal to the square of the modulus of that vector. A dot A is equal to A, the modulus A squared. Okay, then draw this diagram. put the angle, and get the result A dot A is equal to 0. Sorry, modulus A squared. A dot A is equal to modulus A. So silence, silence. Focus on what you are writing. Just don't copy paste the board and talk. And soon after you are done, just stop talking because I have given time. See, you can just look around to see how many students are still writing. So when you start talking after I give something, and even if after I give you time to solve a problem, when you start talking, I think that you are done. Then what I do, I start like solving the problem. But half of the class is not done yet. Still, you can look around. No, some are still writing. So I need to give time for all. Soon after you're done, just don't be that selfish. Small things. Soon after you're done, just don't start talking because when you like when we have a when we hear this small sound from somewhere, everyone starts talking. Then I'm moving on to the next one because that specially happens because there are like different levels of students. No, we have to like as a teacher and as a tutor, I need to understand that no, because this is not a class, and any class there won't be a class where every student is are like high level students. There are students from every level, so we have to cater everyone. We have to take care about everyone because you are coming here trusting me that I'll be guiding you to your success, no? Success of combined maths. So I need to take that responsibility. I'm obliged to that. So what happens if there are a weak student and then he or she is getting the help of the board and trying to understand, and because you are shouting, because you are like all are talking, I'm moving on to the next one. So then what does that student do? Just looking at the board and writing it fast. Just just copying down the solution. He or she never tries to understand within the class and move on to the next one because I have been giving question by question. So don't do in that way. Yeah? We just don't be that selfish. It's really hard. And every time I can't just take care. This is like a daycare center. No? This is a grade 12 class, and even at the school, 2026 ඔය අයියලක්කල එන්නෙත් නෑනේ ගොඩක් ඉස්කෝලේ වැඩි. දෝගොල්ලෝ තමයි අයියලා වගේ ඉන්නේ. This is not a grade 2 pink, grade 2 අරලිය දෙක මානෙල් එහෙම පන්තියක් නෙමෙයිනේ. This is a proper grade 12 class. And in within few months, like 3-4 months, you will be the most senior batch in the school because then grade 13 are not even coming school. Okay, so I can't like behave like the caretaker of a daycare center. Okay, silence, silence, silence. Hey, get up. Hey, get up. Hey, zone out. Come from this one. Come to this one. I'm not used to that. I haven't done preschool education training. Nah? Okay. Listen. So then, write number 5, dot product between ij vectors. Dot product between ij vectors. Dot product between ij vectors. Okay, so what are ij vectors? Ij vectors are unit vectors to the horizontal direction and vertical direction. Ij vectors are unit vectors to the horizontal direction and vertical direction. And I know those are unit vectors. So unit vectors means modulus I is equal to modulus j is equal to 1. Now look at this. What can you say about I dot j? What can you say about I dot j? I and j are two what? Perpendicular vectors. So when the two vectors are perpendicular, the dot product is equal to 0. So we just learned that when the two vectors are perpendicular, the dot product is equal to 0. So I dot j is equal to 0. We can use these results directly. What can you say about I? What can you say about I dot I? What can you say about I dot I? I squared. First one is I squared, not I squared. Modulus I squared. Modulus I squared. What can you say about modulus I? I'm just showing that we make in English. What can you say about modulus I? It's 1. Now then this becomes 1. So I dot I becomes 1. You can use this result directly. I dot I becomes 1. Similarly, J dot J is even equal to modulus J squared. A modulus J is equal to 1. So J dot J is equal to 1. J dot J is equal to 1. So you can use these results based on Ij vectors. Okay. Write down these Ij vectors. Both the two Ij vectors are perpendicular. So I dot J is equal to 0. I dot I and J dot J is equal to 1. Is equal to 1. Again, the online class students reply me to that question about recordings of modulus graph. Were you referring to the website? Because let me know if they have taken, as I know we won't take down the recordings. So if you were referring to the website or you wanted me to upload the modulus graph recordings to YouTube. Okay, now look at question number 24. Question number 24, sub question 1. A is equal to 2I plus J and B is equal to 3I plus 4J. Second one, A equals I minus J, B equals silence, I minus 2J. Okay, find A dot B in the following vectors. Now look at this small thing. Now look at the board, focus. Okay, look at the board, small thing. I know everyone, you can do this. Hey, look at the board. Okay, hey. A dot B. So what is A dot B? We have 2I plus J dot 3I plus 4J. So this dot product is for the vectors because when we have two scalars, we don't consider the product. No. So even though it's a cross product or dot product, 2 into 3 is 6. So that is 6. So this dot product is for the vectors. So now when you multiply these two, what happens? So this is a normal way that you simplify the brackets. You know, this multiplies by this, and this multiplies by this. And then this one multiplies by this multiplies by this. Okay, now when you multiply this, how do you do this? The two constants whose coefficients multiply separately, 2 into 3 is 6. We have I dot I plus 2 into 4 is 8, I dot J. 1 into 3 is 3, we got J dot I. And 1 into 4 is 4, we got J dot J. So I told you we can use these results directly where I dot I is equal to 1, I dot J is equal to 0. I dot J and J dot I commutative property both are equal. This is even 0 and J dot J is equal to 1. So then I get the result A dot B is equal to 6 plus 4, it's equal to 10. So that's why I told you the result of a vector dot product is a scalar. It's a magnitude. We just get the answer 10. Not a vector, no direction, just 10. Okay, so now when you're doing this, you know this I dot J and J dot I is 0. Bindu hai kya dannu? I dot J and J dot I, you know that is 0. So because you know that, you don't have to write it. You don't have to write it. You know that is 0. So what can you do? For the first one, just write and show it. But when you go with the other two, This is all what you have to write. You don't have to write I dot j and j dot I. Just consider the product between these two and these two. That's all. So then the coefficient is 1, 1 into 1. Here we have I dot I. Minus j into minus 2 is plus 2, j dot j. Then I know I dot I is 1, j dot j is 2. So then you can get the answer as 3. So since we know, like, write I dot j, j dot I in the first one, but then after you don't have to write it because you know those two becomes 0. Then you might ask the question, sir, we don't even have to write I dot I and j dot j. We know that is equal to 1. You have to write some vectors. No, if not, like, you can directly come from here to here, no, without writing anything. 1 into 1 minus 2 into 2. It's correct. Okay, so do first one, second one, and fifth one. So only in the first one, write I dot j and j dot I. Do these two and do the fifth one. We can all do all the 5 because anyways we need to homework. No? Do all the 5. Hey, don't look at the board. Just multiply. Small thing. Do all 5. I'll be only doing the fifth one after this. Okay, so question number 3, it's minus 12 plus 28. So it's plus 16. Question number 4, it's 15 minus 1, it's 14. And question number 5, it should be 6 minus 10 minus 4. So A dot B gives you 6, I dot I minus 10, j dot j. Both are 1. So it's 6 minus 10. So A dot B is equal to minus 4. Okay, A dot B is equal to minus 4. Okay, A dot B is equal to minus 4. Okay, then I'll give you some time to think. How can you do the next question? Look, this question 25. Just read the question and try to do it alone. Question number 25. And if there's anything unclear, you can ask from me. Try to do it. I need to see how you think. Question number 25. Try to do the question. I need to see how you do it. Just at least start from the product. So we need to show that the two vectors a plus b and a minus b is 0. 0, sorry, it's perpendicular. Okay. Okay, so silence. Silence. Okay, now what we have to do is, why I say silence, when I say silence, shut up your mouth, that's all. Can't repeat. I don't have to say silence like 5, 6 times in this class. Even the single medium class, only one. That's all. Show a bit of respect. Okay. So here they have given a condition if modulus A is equal to modulus B. So that is what they have given. And we are supposed to show that two vectors are perpendicular. So I told you, how are we going to show that two vectors are perpendicular? We need to show that the dot product between the two vectors is equal to 0. We need to show the dot product. So start from the dot product of the two vectors that you are supposed to show perpendicular. So then I have A plus B dot A minus B. Because my intention is to show that this is equal to 0. My, in, my intention is to equal that this is to show that this is equal to 0. And now when you multiply this, it's a dot A minus A dot B plus B dot A and minus B dot B. So when you multiply in the same way, A dot A dot B and B dot A and minus B dot B. Okay, then it's clear this A dot B and B dot A, those are commutative, so these two are the same, it cancel off. What can you say about A dot A? What can you say about A dot A? What is A dot A? 1. A dot A is not 1. I dot I is 1. A dot A is not 1. So is A dot A is 1. B dot B is 1. 1 minus 1, 0. So then why do we need this condition? If 1 minus 1 is 0, why do we need this condition? A dot A is equal to the modulus of A squared. Minus modulus of B squared. So that's why they have given the condition that modulus A is equal to modulus B. Modulus A is equal to modulus B. Okay, then I have A plus B dot A minus B is equal to 0. When the dot product of two vectors are 0, you can say therefore A plus B and A minus B are perpendicular. The two vectors are perpendicular. A plus B and A minus B are perpendicular. Okay. We can do this and think the same question, but the condition have been changed in question number 26. So do this. After this, think question number 26. Same question, the order that they have asked the question is different. That's all. The order that they have asked the question is different. Question number 25. Then do next one, 26. 26. Yeah, so who have been in school this month? These guys, anyone else? No. Okay. Okay, do question number 26. Okay. Okay, now look at this, how they have asked this question. Silence. They have asked the opposite of this one. If modulus A, silence. If A plus B and A minus B are perpendicular, we are supposed to show that modulus A plus modulus B is equal to 0. Now try to understand this point. Okay. If we want to show two vectors are perpendicular, what we have to do, consider the dot product, simplify, and show that it is equal to 0. You need to show that it is equal to 0. But now they have given that A minus B and A plus B are perpendicular. So they have given that it is perpendicular, which means we can consider the dot product between these two is equal to 0. Previously, we had to show that it is equal to 0. And here, we can consider that it is equal to 0 because they have given it is perpendicular. Clear? So when we have to show that two vectors are perpendicular, what should we do? What should we do? You're not talking like when I ask a question, you're not talking. Every other time you're talking. Tell me, when we are supposed to show that two vectors are perpendicular, what should we do? What should we do? We need to consider the dot product, simplify and show that it is equal to 0. If they have given as a data that two vectors are perpendicular, then what can we say? If the two vectors are perpendicular, we can write that the dot product is equal to 0 as a data. So now they have given this is equal to this. Previously we had to show this. We have to show this. And now this one is a data. Okay, now when you simplify this, it's A dot A plus A dot B minus B dot A minus B dot B is equal to 1. Commutative, so A minus A dot B, B dot A is the same. Okay, now you know A dot A is not 1, that is modulus A squared minus modulus B squared. And then you have modulus A squared is equal to modulus B squared, which means modulus A is equal to B. Clear? Which means modulus A is equal to B. So try to understand the difference. When we have to show two vectors are perpendicular, you have to simplify and get that the dot product is 0. When they have given that two vectors are perpendicular, you can use that the dot product is equal to 0 as a data. Okay, hands up who got this one, 26. Okay, then just write in this way, put a star mark. So write this under question number 26. Put a star mark and write this under question number 26. If the question states that two vectors are perpendicular, we can consider that the dot product between the two vectors, is 0, that's all, is 0. Okay. Then under question number 25, put a star mark and write in this way. Under 25, write in this way. If we are supposed to show that two vectors are perpendicular, we need to simplify the dot product. Between the two vectors, and show that it is 0. Okay. Okay, then you can get ready to go. Okay. Okay, silence now. Listen. So two things. Okay, so two things. First thing is I have uploaded a trigonometry homework tute, which consists of all these trigonometric silence. Listen. Okay, these formulas we have learned. So next week I'll be checking it because I need you to do it, because next week we will be finishing vectors. So next week is December 1st, no, today is the 25th. Today 25th, so 32nd means December 2nd. So December 2nd, so next week we'll be finishing vectors, and December 9th we will be starting trigonometry sine theorem. Trigonometry sine theorem, because before moving on to trigonometry sine theorem, we got 2 weeks more. So I'll be uploading even another tute by next weekend. So I need you to complete it, do it in a separate paper, not in the book. Like maybe some of the questions are same questions from the tute, that is okay. Do it in a separate paper, write your name and staple it and bring it next week. Bring it, like I'll even put a reminder because I know everyone here are doing homework, but you forget to bring it to the classroom. So that's what happened. There's no one who don't do the homework. So bring it to the classroom because I'm doing that as a help. So then it reminds you all the formulas of trigonometry. So then we start sine theorem and cos theorem. You can easily. Hey, Martin, the phone එක බලන්න. Still I'm talking. Okay, you're not tracking the train. කෝච්චිය මොකද අල්ලනවා නෙමෙයිනේ. ඉන්නවා. කතා කරලා යන්න දෙන්න මම බලන්න. Okay. Stay after the class. මම පොඩ කතා කරන්න ඕනේ. So make sure like you do it so then you can smoothly start the second part of trigonometry. නැත්තම් ඒක කරන්න ගියාට පස්සේ sin c plus sin d you can't remember. That happens. That is the first thing. And the other one is next week we are having the main paper 3. So we have like you have 5 time slots to write the paper. Don't ask for any time slot again because I'm giving 5 time slots. Monday evening, give Monday evening, and even I can give Monday morning for you because Monday morning we are having a single medium extra class, coordinate geometry. So for you, you got 6 time slots. Monday morning, 8:30, evening, 3 o'clock. Okay, no, let's start with 9. Monday morning, 9, and evening, 3. Tuesday morning, 9, and Tuesday evening, you don't have a time slot. Tuesday morning, you can come and write the paper by 9 o'clock. And Friday, you have 2 time slots in morning and evening. So altogether, it's 5, not 6. Monday morning, evening, Tuesday morning, Friday evening. All the morning time slots are 9, evening time slots are 3. But I advise you to come and write the paper on Friday. The reason, because we are doing most of vector past papers next week. So if you come on Monday or Tuesday morning, you might find a bit hard to do some of the vector questions, but mostly you can do the vector addition questions. So better to come on Friday and write the paper on Friday, either morning or evening. So then you are even completed with vectors and you can do it easily. So all the lessons that we have completed so far, including coordinate geometry and log, will be coming. So I'll ask the admins to put a message mentioning the dates. But my advice is if you can come on Sunday, better to come on Sunday because then you can even do the vector questions. It's not Sunday, Friday. Sunday in Friday. Okay. Make sure everyone should write the paper. Unless if you are a new student, you can skip this paper, but write it because you will be having a term test in December at school. Before that, you have a experience of then 3 papers and then you can go and write it. Clear? Okay, so how many time slots you got? 5. Monday morning, Tuesday morning, Friday morning. 2 evenings are Monday evening, Friday evening. What is the time, morning time slot? 9, evening time slot? 3. So it will be a 2 hour and 45 minute paper. Clear, no? Okay, so we are done for today. You can go home safe.